So this shows a family of Ponceletian triangles described in a circle and circumscribing the so-called MacBeath ellipse. This ellipse has foci on um, the circumcenter, x3, and on the orthocenter, which is an isogonal conjugate of x3. Now you can see that for this family, the barycenter and the center of the 9-point circle, the Euler center, are also stationary, which is quite remarkable. Now this video shows a very interesting property that this family conserves, by definition, the circumradius, since it's circumscribed, but it also conserves the sum of the double angle cosines, shown down here, the product of the internal cosines, and very interestingly, the sum of side lengths squared. Okay. Now, this is in a way an analog to, let's put here the confocal family. Okay, you can see here that for the confocal family, so I have these dashed red triangles. Let me change the aspect ratio here a little bit of the caustic. So these dashed red triangles are interscribed between an outer conic and a confocal caustic. So this is also called the elliptic billiard. And you can see here that this family, though those 4 triangle centers that we mentioned before all lie on the Euler line, x2, x3, x4, and x5, so these 4 points here are collinear, they're actually sweeping ellipses. So they used to be stationary on the previous case, but now they're sweeping ellipses. But the interesting thing of this family is that it conserves the ratio of in radius to circumradius, okay, which leads to this other conservation, which is the sum of cosines. But it also conserves the sum of side lengths. Compare this with the MacBeath. Let's go back to the MacBeath, which conserves not the sum of side lengths, but the sum of side lengths squared. Okay, and now these 4 points here that do lie on the Euler line, and now the Euler line is basically the horizontal line, they are stationary. Okay, so this is all I got for now. See you on the next video.